1-1 3 5, huh?
Portable in Tasmania, and I just worked in double side van on the Oz QRP, which I haven't had out for a long time.
Welcome to the show where the circuits glow. Morse code never dies in home light skies. Transistors and waves.
Jinque! Hi folks, welcome to another episode of The Art of Engineering. The last episode I did was a nostalgic look at the DX160 realistic single conversion super heterodyne receiver. Here it is in the background. And that video did gangbusters by my channel standards, so thank you to all the people who really enjoyed the video and commented on it. It was really encouraging to see the amount of interest in that old technology, and I think it stirred a lot of childhood memories for a lot of people. It certainly did for me. To continue on with the theme of receivers, I've decided to go the QRP Labs route. And for those of you that watch this channel, you know I'm a huge fan of QRP Labs. I've built a myriad of kits, so take a look at the hand playlist to see just all the kits that I have built. I love Han Summers' designs, and I think I really want to encourage people to go to that site, qrplabs.com, I'll link in the description, and just see the magnificent stuff he has. But I decided to go the road less trodden, and that is an earlier kit that I think was around in about 2016. It's still for sale, and it's a receiver module, and it's got a tailor detector in it. It's a great little receiver module, and it can be used with SDR software, but it can also be a standalone receiver. And the idea with this receiver is to put it in my AOE monster here in the background, here behind Brains from the Thunderbirds. And the AOE monster has a receiver design that's quite a good design. It's a Drew Diamond design, but unfortunately it's poorly constructed by me, and so the receiver is very, very deaf. So I really want to get into this AOE monster and rebuild it and make it work well. So that will be in an upcoming video. But in this video, I am going to show you the QRP Labs receiver module as a standalone receiver, teamed up with the QRP Labs VFO, which I've already covered in another video, a link in the description below. And what I'm going to do is also build the polyphase network. Oh, this stuff sounds so technical, doesn't it? It makes me sound like an absolute genius, but as you all know, I am a bona fide clown. Now, I did have some footage of me building that kit. Unfortunately, we've lost that footage, and it's probably good for you because it would have been very boring for you anyway. And as you will all know, if you've built a QRP Labs kit, Han Summers provides very, very detailed instructions as to how to build, so you don't need to watch me muddle my way through it and miss half the steps. So without further ado, let's jump over on the test bench and have a look at all this good stuff, and then we will do a demonstration of the receiver, and you will get to see how well it does or doesn't work. Let's go. Well folks, we thought this moment would never come. We're finally back on the test bench. Ladies and gentlemen, I present to you the QRP Labs receiver module. Now, I did have a bit of footage of me building this, and of course, had to change over the iPhone. I'm a little bit behind the times. I went from the iPhone 7, which is now no longer supported, to the iPhone 10, which probably shortly will be not supported as well. So I'm way behind the times, but I hate spending money on this stuff. So people give me these phones and I'm happy to take them. So quite often the older phones are used for the filming of these videos. So this is the QRP Labs receiver module kit, and I'm hoping it works well. I'm assuming it will work well because it's a Han Summers design. And earlier in the video making process, ladies and gentlemen, I present to you the QRP Labs VFO. Now, this VFO is actually designed such that the boards stack really nice together. And I managed to get the plug for this on the wrong side of the board. I made a complete stuff up of the building of this, but it works and it will team nicely with this receiver, I've been told. So that is the QRP Labs VFO Kit. I also present to you, ladies and gentlemen, the QRP Labs Bandpass Filter Kit. Now, you can buy these bandpass filters and also low pass filters as kits from QRP Labs. Great for home brewing and a great way to knock up a filter. It's quick, it's easy, and we know it's proven as a design. These three things are going to be going into a receiver. Perhaps down the track, the plan is to maybe make a general coverage receiver standalone. Now, how are we going to make this standalone without the SDR software? Well, ladies and gentlemen, I present to you the final piece of the puzzle, and that is the QRP Labs Polyphase Network Kit. Now, I haven't built this kit yet, and the plan is once I've got this working, this will be used to improve my AOE monster receiver and make it really great. So the bandpass filter for 40 meters is completed. I need to get the center frequency adjusted on it. And so I've got these, I think they're called SMA connectors. I've got the necessary cabling with the VNA, so I'll be able to attach these. I'll keep these with my Nano VNA for further testing whenever I need to do that. Of course, our meter's telling me it needs to be switched off. And so we'll get that plugged in and test for the response and adjust it for a center of the 40 meter band, 7 megahertz. Now, even though this is low frequency, so we could probably get away with doing the calibration at the actual port, we're going to follow reasonable practice by doing our calibration at the ends of the leads. To take into account the length of the lead on this vector network analyzer, try and saying that after you've had a few beers. Okay, so get our calibration slugs. We have it set to 6 to 8. So if you want to set your stimulus, you'd go stimulus, start, we'll go from the beginning, 6 megahertz, stop, 8 megahertz. Now, I don't know if that's a wide enough passband, but we'll see. And then we're going to go to our back, hit back, and we're going to go to cal. We're going to go reset. Reset. Then we're going to go calibrate, and then we start the whole process. So on the 0 port, we're going to get our open slug, and we're going to need a little joiner, this little joiner doohickey, so that we can plug in our slugs. So we'll go like that, get our open, screw that in, and hit open. Now we're going to short, which is the one, you can tell it's a short because it's metal at the bottom. So the pin's surrounded by metal. We're going to go short circuit. Then we need to go load. Now, isolation. I have watched the videos on this, and most people say for isolation that obviously it's isolated, but they also say to put your 50 ohm slug on channel 1. So that's the other port. So I'm sure there's a technical reason for that, but people way smarter than me have told me to do that, so that's what we're going to do. Hit isolation, and then finally we join our cords together, and we do our through, and then we are done. We're going to save it in posi 0, and that is our calibration done. We want to set ourselves up for our channel 1 trace to be mag log. So if we go back and we find the display, we need to find channel. Let's go config. Nope. Now we need to find channel. If we go display, so hit display, and then we hit channel 1. So now we're on channel 1, and then we'll go, let's go format, let's go log mag. So channel 1 is now set to log mag. I'm going to get rid of stuff that's going to confuse me. So we're going to go back, trace, I'm going to turn off trace 2. So we have log mag on channel 1. So we're going to plug in our filter and see if it's doing what it's supposed to do. Should be interesting. So after playing around with taking a loop off each side and tweaking those capacitors, we've managed to get ourselves to the point where we've got a minus 0.75 insertion loss and a nice looking bandpass filter curve. So I'm happy with that. I'm not sure exactly how accurate that is. I'd think that insertion loss is probably lower than it really is. But it's certainly, I've recalibrated a couple of times and it looks like that's what it is telling me. And I would like to believe that. So we will pop this into the receiver now and see if we can get the receiver going. Hey folks, while we're playing around in the shack, thought I might show you this extension lead that I've made up. And I know, hey, not really exciting stuff, an extension lead, but the plan is to take this lead over to the test bench. So I've always got access to the antennas when I'm playing with my homebrew gear. Can connect up to receivers, transmitters, all that good stuff. But the reason why I'm showing you this lead is because I have used a new type of connector. Instead of using the crimp-ons, which I've had some major issues with, quite often I'll buy a crimp-on connector and the pin won't fit on the center conductor because it's stranded rather than solid, or and I'm sure you can find the right type for the right type of cable, all that good stuff. But what I found is they quite often fail, at least mine do. Now, my mate VK2 AOE put me onto these connectors here, and they are a P601 from Wes Components, and it says here it's I'll just read so we get it correct. It's a BNC plug RG58 type P601, and the great thing about this is the center pin is a solder-on connector, and the actual braid is then screwed down onto. So I'll just show you what we've got in here. This is the actual connector, and there's a whole lot of other stuff that goes with it, and you can find online the instructions for putting these together, so I'm not going to bore you with all that, but as you can see here, that's the screw down part. So preparation of the cable seems to be so much easier, and I found that connecting or making up this cable was a lot less stressful than it normally is for me. So I just thought I'd show you that. I've got a whole heap of them, and as cables fail or as I need to make cables, I will be able to do that quite easily. Anyway, I'm going to install that cable into the mix. Also, hey, while we're doing show and tell, also from Victor Kilo 2 November Alpha Papa, I was at his place looking at his collection of keys and talking all things radio, and I noticed this, and he said, hey, do you want it? And I said, well, look at that, how could I not want it? So it's about a case of beer, I think, and it's 120 or 30 watts, and it's a VHF dummy load with a power meter. and I think that is so cool. And it says here 30 to 500 megacycles probably for the calibration, but as a dummy load, what a great thing to have on the bench. So I've got the adapter for that to make it BNC, and that will be going on the bench as well. So lots of fun stuff happening in the shack. Now you'll probably notice if you can read the VFO display, it's reading 28 megs, and that's because you feed a oscillator frequency that's 4 times the required frequency into this receiver, and it's working. I am a little bit concerned about how low the audio is. I think this is a VK4 station. It's a single sideband of 40 meters. Very, very soft. I'm not happy with the volume coming out of this thing, so I don't know what I'm going to need to do about this. We've now got the 4 times the frequency for the local oscillator set up in the VFO, so it's giving us the correct frequency readout. And this is a bit of sideband, but it's very low. So I don't think we have a problem with sensitivity. This is 2 stations in South Australia, about over 1,000 kilometres away. I'm having a quick look at the polyphase network. And there's a section here that says IC6B is a final audio preamplifier whose gain is adjustable by the 100K preset potentiometer. This stage can be used to boost the audio output levels, suitable for driving an audio power amplifier for applications where this module will be used as part of a standalone receiver. When used to drive a mono input sound card, R42 setting is typically very low gain. So we probably have low gain for a good reason, because we don't want to overdrive the sound card. So maybe this isn't as bad as I thought. So this is our QRP Labs module. And let's flick it over to the DX160. Single conversion. It's a pretty hot receiver. Now, to give this its dues, we presently don't have the polyphase network, so it's basically a direct conversion receiver. So we're getting a lot of image frequency chatter and whatnot. I'm certain that this will sound a lot better once we install the polyphase. But sensitivity wise, working fine. But yeah, the DX160 holding its own. 1970s single conversion super heterodyne architecture. It's Monday afternoon and we are in the QRP Labs site. We're going to download the polyphase network for removing the unwanted sideband from my receiver module, and we are going to build the polyphase network, or at least make a start on it. School night, so I can't stay up too late, but let's get started on it and get it plugged in and see how it performs. And that is the completed polyphase network to remove the unwanted sideband. We just need to throw the headers into the actual receiver board as well now, and remove the unwanted capacitors that are on the main receiver board for the install of this, and we should be good to go. And that is the completed polyphase network installed in the receiver. Let's go and see if it works.
Okay, I'll let you go. I've got other patients there, and I see your VK2 AOE portable.
113 huh? Hey, good on you, Gerard, and a good evening to you. Sounds like you've been making some nice catches. Apart from, that is, of course, good Tasmanian salmon. Thanks for the 5 and 9, the 5 and 9 plus 10, over.
Oh, okay. 5 and 9 plus 10, yeah, very good.
Yeah, I've been sampling some of the locals here, you could say. Alright, thanks Dan, nice to work here, receiving. And VK2 1135 the park, just south of Hobart. Yeah, very good indeed. 1135. Thanks, Gerard, 7344. Catch you soon then, have a great night. 73.
Well, that's Gerard. I think he's the VKFF Flora Fauna rep for New South Wales, and he's out doing lots of activations. I've run into him on numerous occasions, done some park to park as well. And as you can hear, this receiver definitely has a good amount of volume now that the polyphase network is in. More than enough to feed an audio amplifier, and then you'll be able to adjust your volume via, well, you can adjust your volume via this trim pot here. But you would be doing it via the volume control on whatever amplifier you install. Obviously some audio filtering perhaps, especially for CW to narrow it down, is going to be the order of the day, but it's looking like it's a goer, and I am very, very happy.
Thanks, George. Have a good evening. Nice to meet you from Hobart. So, 7344.
That was Gerard. I just hit record at the last minute. He's portable in Tasmania, and I just worked him double sideband on the Oz QRP, which I haven't had out for a long time. He was barely reading me, which is unsurprising. I'm putting out about 4 watts double sideband, which is 2 watts sideband. But it's nice that he got me. So, hey, I thought I'd throw that in there. Well, folks, if you're still here, you've lasted to the end of another quite long episode of The Art of Engineering. Thanks for sticking around right to the end. Please remember, if you haven't already, to like and subscribe. It encourages me greatly, and it doesn't cost anything to do so. 7-3, and I shall see you in the next episode of The Art of Engineering.